Exploring brackish water desalination techniques. Exploring brackish water desalination techniques. Water scarcity is a pressing global challenge that demands innovative solutions. As freshwater resources continue to deplete due to factors such as population growth, urbanization, and climate change, the need for alternative sources of clean water becomes increasingly critical. One such source that holds promise is brackish water, a mixture of freshwater and seawater with salinity levels higher than freshwater but lower than seawater. Brackish water desalination techniques have gained attention as a viable means of expanding our water supply. In this article, we will explore the various brackish water desalination techniques and their significance in addressing water scarcity. Understanding brackish water desalination. Desalination is the process of removing salt and other impurities from seawater or brackish water to produce fresh water suitable for various purposes. Brackish water can be found in various sources such as rivers, estuaries, groundwater, and even certain aquifers. However, the high salt content poses challenges for its use in agriculture, industry, and potable water supply. Therefore, effective brackish water desalination techniques are essential to make this resource accessible and usable. Popular brackish water desalination techniques. Several techniques have been developed for brackish water desalination, each with its advantages and limitations. Some of the most prominent techniques include 1. Reverse osmosis, RO. Reverse osmosis is a widely used desalination technique that relies on a semi-permeable membrane to remove salts and impurities. Brackish water is pressurized and forced through the membrane, allowing only water molecules to pass while blocking salt ions and contaminants. RO is energy efficient and capable of producing high-quality freshwater, making it a preferred choice for brackish water treatment. 2. Electrodialysis, ED. Electrodialysis utilizes an ion exchange membrane to selectively remove ions from brackish water. By applying an electric field, ions are attracted to oppositely charged membranes, leaving behind desalinated water. This technique is particularly useful for water sources with moderate salinity levels and is less energy intensive than some other methods. 3. Multi-effect distillation, MED. MED involves the use of multiple evaporator stages to distill brackish water. As the water is heated in each stage, it evaporates and condenses to produce fresh water. The process is driven by the temperature difference between stages, reducing the energy required. MED is suitable for brackish water sources with higher salinity levels. 4. Solar desalination. Solar desalination harnesses solar energy to drive the desalination process, making it environmentally friendly and cost-effective. Solar stills, solar-assisted RO, and solar-driven multi-effect distillation are some of the solar-based techniques used for brackish water treatment, especially in regions with abundant sunlight. 5. Forward osmosis, FO. Forward osmosis involves using a concentrated saline solution as the draw solution to create a natural osmotic gradient across a semi-permeable membrane. Water from the brackish source moves through the membrane into the concentrated solution, which is then separated to retrieve fresh water. FO has gained attention for its low energy requirements and potential use in treating difficult-to-treat water sources. Factors influencing technique selection. For instance, regions with ample solar energy resources might find solar desalination techniques more suitable, while areas with access to reliable electricity might opt for RO or ED systems. Additionally, the scale of the desalination plant, maintenance requirements, and cost considerations also play a significant role in technique selection. Challenges and future directions. While brackish water desalination holds promise, there are challenges that need to be addressed to ensure its widespread adoption and effectiveness. 1. Energy consumption. Many desalination techniques, including RO and MED, are energy-intensive processes. Finding sustainable and cost-effective energy sources to power these systems is crucial to mitigate their environmental impact and operational costs. 2. Brine disposal. Desalination processes generate a concentrated brine stream with higher salt content than the source water. Proper disposal of this brine, without harming the environment, is a challenge that requires innovative solutions. 3. Membrane fouling. In membrane-based techniques like RO and fouling, accumulation of impurities on the membrane surface, can reduce efficiency and increase maintenance needs. Developing improved membranes and fouling prevention strategies is essential. 4. Economic viability. The cost of brackish water desalination, including installation, operation, and maintenance, can be a barrier to its widespread adoption. Continued research and technological advancements are needed to make these processes more economically viable. 5. Environmental impact. The environmental impact of desalination, such as the carbon footprint and ecosystem disruption, needs careful consideration. Implementing sustainable practices and minimizing negative consequences are critical. Conclusion. Brackish water desalination techniques offer a promising solution to the global water scarcity crisis. By tapping into brackish water sources and converting them into usable freshwater, we can alleviate the strain on traditional freshwater resources and support various sectors that rely on water. As technology continues to advance, addressing the challenges associated with brackish water desalination will become more feasible. Innovations and future prospects. Researchers and engineers are actively working on innovations to enhance brackish water desalination techniques and overcome the existing challenges. Some of the advancements and future prospects in this field include: 1. Advanced membrane materials. Improving the efficiency and durability of membrane materials is a priority in desalination research. Scientists are developing membranes that resist fouling, require less energy for operation, and have higher selectivity for salt removal. These innovations could greatly enhance the performance and longevity of membrane-based processes like RO and FO. 2. Energy recovery systems. Energy recovery devices are being integrated into desalination plants to minimize energy consumption. Devices such as pressure exchangers and isobaric chambers capture and reuse the energy from the brine stream, reducing the overall energy requirements of the system. 3. Hybrid systems. Hybrid desalination systems combine multiple techniques to maximize efficiency and address specific challenges. For example, coupling RO with capacitive deionization, CDI, can help recover valuable ions from the brine while producing freshwater. 4. Decentralized desalination. Small-scale, decentralized desalination systems are gaining attention, especially in remote and rural areas.